Welcome back. In this lesson, I'm going to just quickly take you through the process of solving for the payment amount. Sometimes it's useful to find out how much the payment needs to be or how much we're going to pay if we're depositing money into a savings account or if we're buying something and getting a loan, for example, buying a new car. What are my monthly payments going to be? Those types of questions are pretty common in finance. We know how to solve for future value and present value. We've got basic formulas for those. What I'm going to do now is just rearrange those two formulas to help us find the amount of the payment. Let's have a look. If you know the future value that you want to achieve, so that would be a type of question where I said, oh, I'd like to have $1 million in my retirement fund when I reach retirement age. How much should I put in every month? So I know the future value. Then I'm going to rearrange the FV formula just by dividing both sides by everything in square brackets, and I'll be left with payment equals future value over 1 plus I to the n minus 1 over I. If, on the other hand, the bigger amount or the big known amount is a present value, so that might be something like a loan where we borrow a big amount of money up front, or maybe the beginning of my retirement days where I have some money in the bank and I'm going to start using it up, that sort of thing. Then I'm going to rearrange the present value formula. And again, just divide everything by on both sides by everything in square brackets. And I end up with payment equals present value over 1 minus 1 plus I to the negative n over I. Let's see how those formulas work. All right, let's have a look at a couple examples here. First one I'm going to look at for you is a retirement one. Sally wants to have some money in her retirement account when she retires. RRSP, by the way, stands for Registered Retirement Savings Plan, if you haven't seen that before. So how much is she going to have to deposit every month into that savings account or that retirement plan if she wants to retire with $1 million? Well, let's assume she can earn 6% in her account and she's going to retire in 30 years. The first question I have to deal with here is this $1 million, is that a present value or a future value? In this case, she wants to have it later on when she retires. So I'm going to make it a future value. That's pretty important to know because without that, I don't know which of the two formulas that we just talked about I should use. Little I was 0.005, n was 360, and we want to find the payment. Well, let's go ahead and have a look at the formula then. This is the one I'll be using, the future value over 1 plus I to the n minus 1 over I. Put our numbers in there. 1.005 to the power of 360 minus 1 over 0.005. Now, some people don't like to try to put all of that in the calculator in one long step. If you'd rather break it into pieces and then divide things through, that's just fine. Pick the way that works for you and make sure you're good at working with your calculator in a way that's comfortable for you. Whichever way you choose in the end, though, if you're doing it right, you should come up with the right answer. In this case, $995.51. If Sally puts just under $1,000 a month aside, she'll be able to retire with $1 million in 30 years. Great news for Sally. If you don't have $1,000 a month to put aside, though, what could you do? Well, I guess you could start a little bit sooner. Add a little bit more time in there, maybe 35 or 40 years. That would definitely reduce the amount. Or you could try to earn a little bit more money, and that would definitely help as well. So if you could get 7 or 8% instead of 6, that would be a big boost to your retirement and reduce your payment. Or you could just decide maybe $1 million's a bit too much after all. I'm going to retire with 800,000 or 700,000 or something like that. So you can play around actually with your own money right now. Or your own numbers, and see what it's going to take for you to retire as a millionaire and see if that's very realistic or not for you. Let's have a look at another example. In this one, I'm going to let you take the lead. It's a car loan question. So John is thinking about buying a new car that costs $20,000. He can get a loan that charges 3% interest for 5 years. If he does that, what would his monthly payments be? So rather than me doing it for you first, I'm going to suggest that you stop right now, hit pause, try this one out, and then when you're ready, come on back and I'll do it with you and see how you did. Of course, your big question that you have to answer first before you get very far is, what is this 20,000? Is that a present or a future value? Because that's going to dictate which of the two formulas that you use. All right, go ahead and hit pause and give it a try. All right, welcome back. Let's see, for this one, I'm hoping that you decided that $20,000 was a present value, because that's what the car cost in today's dollars, isn't it? So that's the value today. He's going to pay it off over 5 years, which is 60 months, and the rate per period or per month is 0.0025. What will his payments be? Well, payment is present value over, slightly different version this time, isn't it? 1 minus 1 plus I to the negative n over I. We plug some numbers in there. And it looks a little bit more like this, doesn't it? Let's you go ahead and work that out on your calculator. And again, if you want to do it, solve the denominator and then divide that into 20,000. Or if you want to do it all in one long stretch, totally up to you. Whatever works best for you. You should end up, though, as long as you've done it correctly, with $359.37. Pretty typical car loan, really, somewhere in that range, that John would have to pay every month. And if he does that for the next 5 years, he'll have paid off the car in full, and it'll be all his. So really, if we take those payments over time, $359 every month for 5 years, or 60 months, that's going to be equivalent to $20,000 down here at the beginning. That's it for payments. Go ahead and work through lots of these. It's especially important, I think, to go back to your textbook as well and practice lots of different wordings of questions, because even though the formula doesn't get much harder, the wordings and the logic behind them gets trickier and trickier, and that's what we'd like to do to kind of build your capacity, is keep giving you harder and harder ones as you progress through them. So make sure you spend a bunch of time in the textbook before moving on to the next section.